This video will summarise your third lecture, exploring coastal and ocean renewable energy examples of clean technologies, and the follow-on workshop in which you should confirm your choice of topic for your desk-based research project. Renewable energy sources for ocean and coastal energy include waves, tides, ocean currents, offshore wind, and salinity and thermal gradients. We will explore these with a focus on their current and potential use in the UK. Considering power direct from the sea as an example, energy can be harnessed through the movement of water as waves, as currents, and as tides. The UK has extensive resources from both waves and tides, with Scottish waters considered to offer the majority of the UK's wave resources. The Pentland Firth that separates the Orkney Islands from the northern tip of mainland Scotland has amongst the strongest tidal currents in the world, caused by the tidal waters being forced through the constricted channels. It is because of this combination of wave and tidal potential that the European Marine Energy Centre, the EMEC, was established in Orkney to trial and develop technologies to harness these energies. There is, however, a complexity of spatial patterns and variability in time of currents and waves to consider, and the difficult to model and predict feedback effects of wave energy converters and tidal turbines on wave patterns and currents. Salter's duck, one of the classic early wave energy converters, for example, captures approximately 90% of the energy of waves passing it, with consequent effects on energy and sediment fluxes. Sediment fluxes, very difficult to model, influence coastal erosion and deposition patterns as well as marine life, such as the scallops shown here, which live on the seafloor as filter feeders and are an important fishery. The policy context has played an important role in shaping the direction of development of all the technologies we consider in this lecture, and change of government policy, with a lack of long-term stability, could be argued to undermine the chances for an effective transformation of electricity generation away to renewables. For each of the examples, you are asked to consider what policies are relevant and to what extent have they encouraged or discouraged technological development. We discuss policy drivers in the full lecture as a class, highlighting too some of the unintended consequences and asking you to think about the wider impacts on different issues and at different geographic and temporal scales. We can in the UK, for example, identify the non-fossil fuel obligation starting in 1990 as a major driver for clean technology, yet at the same time its biggest beneficiary is agreed to have been nuclear power. Can we consider nuclear power clean technology? With evident environmental impacts beyond carbon prominent in opposition to nuclear energy, does this make you think again about the lack of consideration of negative environmental impacts in public discourse about other non-fossil fuel electricity sources? Beyond counting carbon emissions, there are a multitude of environmental, social and economic factors operating at various scales that we should consider for clean energy technologies. In the full lecture, we will discuss in detail the issues associated with a number of further renewable energy examples associated with coasts and oceans. The UK, for example, is a global leader in offshore wind exploitation, and we discuss why, with a particular comparison to the restrictions faced by terrestrial wind farms. We look at tidal flow barrages, using the Severn Estuary between England and Wales as a case study, and artificial tidal lagoons. We discuss integrating offshore renewable energy generators in national power grids. What about balancing supply and demand timings? How can power storage and transmission be managed? Offshore installations can have both positive and negative effects on wildlife, and the overall balance is very much dependent on effective consideration, planning and management. For these various technologies, you can see how different perspectives and different values will play an important role in an overall evaluation. This again emphasises the importance for your assessment of establishing criteria to evaluate the potential of a chosen clean technology. It also highlights that we are looking for a critical evaluation that explicitly recognises costs alongside benefits and considers how they can be mitigated. You would ideally come to the workshop ready with one or more proposed titles, in which case we can confirm their suitability, look to improve your chosen title, and advise on criteria and theoretical frameworks to use. As a minimum, you should come to the session with some broad areas from which to finalise a topic and title. We will then work in groups to discuss your ideas and develop your plan for your desk study and extended essay. By the end of the workshop, You should be able to describe the topic and the questions being asked, justify and explain the critical framework you propose to use, and consider the implications of different perspectives encountered in your initial reading.